Welcome to this hands-on presentation of Technicolor HDR solutions implemented on Cobalt 9904 conversion cards. In this part of the webinar, we will show you how you can easily produce and distribute high-quality HDR starting from a live SDR or HDR video stream. We will start from the block diagram we already detailed, representing a typical production chain that was used, for example, by TV Globo for their Rock in Rio event in October 2019. In this hands-on demo, we will focus on how Technicolor HDR solutions can contribute to the production, the distribution, and the rendering of the video. Starting from the left, you have a live SDR BT709 video. The first step is then to upconvert this to an HDR10 BT2020 signal. To generate a high-quality HDR signal that you can mix with native HDR content, you can use Technicolor HDR ITM that dynamically upconverts SDR to HDR. Once you have a high-quality HDR video, with the second Cobalt card integrating Technicolor HDR, you can generate an SL-HDR stream to use for distribution. This is what Sinclair is doing in the US, using SL-HDR1 as distribution format. SL-HDR1 is a single-layer SDR video with dynamic metadata. This video stream is then encoded, here with an ATEM Titan Live encoder as used by Arte, TV Globo and Sinclair. Your video is now high-quality SDR content, compatible with any legacy TV. And with the same video stream, SL-HDR-enabled devices can reconstruct the native HDR and also optimize it to their specific display capabilities. To detail each individual part of this chain, we will split the demo in three parts. First, the SDR to HDR conversion using Technicolor HDR ITM or Intelligent Tone Management solution. Next, we will show you how you can, from high-quality HDR content, create a high-quality SDR version for SL-HDR1 distribution. Finally, we will show you the benefit of the SL-HDR1 distribution format for end users and which qualitative image they can see depending on their display. During the first part of this hands-on demo, we will start with ITM, our intelligent tone management solution that is dynamically upconverting the SDR input video into a high-quality HDR video. What you will see live is the following. On the left side, the user interface of Technicolor ITM on the Cobalt card. On the top right, the oscilloscope measuring the generated HDR. On the bottom right is the HDR output image, down-converted to SDR for the purpose of this webinar. Before we start, we wish to make clear that what you see right now in this webinar is an SDR image. This means that during this hands-on demo, we won't be able to show you a real HDR image or the benefits that you can achieve when producing in HDR. However, we've tried to build a demo that shows some concrete examples of what you can do with Technicolor solutions and illustrates some of the effects of the different setups. So here we go with the live demo. As you can see on the Cobalt interface, we are here on the ITM user interface, and we start by specifying the characteristics of the input video we have. The SDR input video can be either 709, 2020, legal, custom or full range, so you need to select the right options. From there, you can decide the format you want as output video in terms of EOTF, color space and range. In HDR10, you can also select the peak luminance you want to achieve. More tuning will be possible later on. In this second tab, you can select which mode you want to run the conversion. Indeed, Technicolor ITM is performing by default a dynamic conversion, meaning that it will analyze and optimize each image individually. Thanks to this approach, you can keep the native artistic intent present in your SDR source and create an HDR with your user preferences. Three conversion models are offered by default. The first one is generating quite a bright HDR. The middle one is emphasizing details in the midtones. And the third one is focusing on details in the blacks. For example, you can see here how switching between two models influences the HDR image, even if what you see is a down-converted HDR image. Typically, a broadcaster will use one of these preset flavors. This is what is done by Arte for their experimental HDR channel, for example. However, if you need to match some predefined HDR characteristics, you can also further fine-tune different elements of this conversion, such as saturation or sharpness if you want to further emphasize the details in HDR. Moving forward to the next tab, here's where you can further optimize the light of your HDR images. To better visualize the effects of these tunings, we will focus on the oscilloscope view of the HDR signal. Following the video engineer's feedback we received during our numerous trials, one of the latest features implemented in Technicolor ITM is what we call adaptive light control. The idea of this tuning is to define the target diffuse white as well as the sizes of the objects you want to consider to calculate and adapt to this. The basis of this feature is fully detailed in ITU BT 2408 Annex 2. Thanks to this tuning, you can benefit from a dynamic optimization for each image while meeting diffuse white targets you might have for your content. As you can see here, the default value is set to a 300 nit target. Now I can also tune it down to 200 nit to meet traditional HLG content. A higher value will however enable to create a more immersive and differentiating HDR. As you can clearly see on the oscilloscope, the diffuse white is indeed moving between 300 and 200 nit. Once the choice is done on the target diffuse white, the process is again fully dynamic and will adapt each image to the target, depending on the image and the weight of the white spots in it. Many more tuning features are available in the Technicolor ITM tool, and we have a specific HDR video explaining them and showing the effects of these tunings on real HDR images. Feel free to contact us if you are interested to experience this. But for this webinar, let's now move to the next part of the production chain, the generation of a Technicolor SL HDR video stream for distribution. So in this second part of our Technicolor hands-on session, we will proceed down a production chain and focus on setting up the encoding stage for the Technicolor SL HDR1 distribution format. This step of the production chain is typically after playout, once a full HDR channel has been produced, and just before the contribution or distribution encoder. As you know, this format means that you can distribute a high-quality SDR video stream with dynamic metadata to reconstruct the native HDR image. This means that whatever SL HDR tuning you do to generate a high-quality SDR, the original HDR won't be impacted and can always be reconstructed with dynamic metadata. To do this, starting from an original HDR video, you can use the SL HDR option on the Cobalt 9904 live conversion card to both generate the high-quality SDR and at the same time the dynamic metadata describing how to reconstruct the original HDR. What you will see in the next live session is then, on the left side, the user interface of SL HDR on the Cobalt card, on the top right, the measured SDR signal, and on the bottom right, the generated SDR video. Here we go with the next part of the hands-on demo, detailing the Technicolor SL HDR features using again the Cobalt 9904 card user interface. In here, you can select your input and output format settings. Once you have set these, you can proceed to the fine-tuning parameters below. For example, some of our customers wanted to be able to produce an SDR with more compressed whites and have maximum control over details in the midtones. Here again, we have then added some tunable parameters to support our customers' requests and to be able to meet their expectations. In this specific example, we can start by using lift to tune the blacks, which can be useful if you have some noise in the source. Then using gain to increase the details in the midtones. Last, you can also specifically change the dynamics in the dark or bright areas using shadow gain and highlight gain. As you can see, this has a direct impact on the distribution of details and overall dynamics of the SDR video. Once you've tuned the conversion to your user preference, you can let the process go live and dynamic optimization will continue for each individual image. These kinds of user preferences can also be stored as presets, and you can define different profiles that can be automatically loaded depending on the input content you run. Night or day scene, sports or movie. In the case of SL-HDR1 distribution, these tunings enable you to optimize the distributed SDR video signal while keeping the original HDR and enable to have them both available for end users depending on their display capability. So let's move now to the last part of the chain, the end user side. What you can see here are two different types of TV. On the left, the legacy SDR TV displays the SDR video signal, ignoring dynamic metadata. On the right side, dynamic metadata are used by a decoder, an NVIDIA Shield in this case, to reconstruct the HDR image and send it to the HDR TV. As you can see, while this is the same single-stream SL-HDR1 video signal, both the legacy SDR TV and the SL-HDR-enabled HDR TV can display a nice image, while of course the HDR TV shows more contrast. This is exactly what can be experienced with the Sinclair ATSC 3.0 transmission that has started on air in the US over the last months. Legacy SDR TVs can benefit from the basic video stream, while HDR content can be visualized by customers with Technicolor SL-HDR1 TVs or set-top boxes. Another important element of Technicolor SL-HDR in general and SL-HDR1 in particular is the possibility to use dynamic metadata not only to rebuild the native HDR, but also to optimize it to the peak luminance of the display. Let's now focus on the HDR TV and take a closer look at how the reconstructed HDR signal is adapted to the specific display capability. Let's take the example of an OLED TV. Typically, these TVs have a peak luminance around 500 to 600 nit. A lot of mainstream LCD TVs are also in this range. The risk with these TVs is that they clip the details available in the content, which are above their display peak luminance between 500 and 1000 nit, for example. Using the dynamic metadata, the receiver has a guide on how to move from 100 nit SDR up to the native peak luminance or to the display-specific peak luminance. You can then decide not to rebuild the native 1000 nit HDR, but an optimized 500 nit HDR, for example. As you can see, this is what the set-top box is doing here, enabling a better viewer experience on 500 nit TVs. We will now add as an overlay to the image some curves so that you can better understand what's happening. Once the maximum capable amount of nits for the TV is decided, each image will be optimized to this peak luminance, and as you can see from this curve, illustrating the conversion between the received SDR signal and the displayed HDR, that for each image the conversion will be optimized. This is the clear benefit of dynamic HDR distribution formats such as SL-HDR1. The same principle applies, of course, on SL-HDR2 or SL-HDR3, the two other Technicolor HDR distribution formats we have detailed in our previous webinar. Thank you for your interest in this hands-on demo. In summary, we have demonstrated Technicolor HDR solutions and the SL-HDR distribution format standardized in ATSC, SB-TVD, DVB and fully described in ETSI TS 103433. A complete chain that is easy to implement, to produce and distribute high-quality SDR and HDR thanks to dynamic conversions available on Cobalt's and Atem's products. The availability of several tuning features to optimize the SDR and HDR quality, and SL-HDR1's capability to distribute on a single video stream a high-quality SDR for legacy displays, and high-quality HDR optimized for any up-to-date HDR display. The demonstration today was based on the Technicolor SL-HDR1 chain used by TV Globo for their Rock in Rio event in October 2019. A similar chain is also used by Sinclair for their ATSC 3.0 next-gen TV channels that are now being deployed in more than 40 cities in the US. In the same concept, Arte's experimental HDR channel is being distributed since December 2019, using this time SL-HDR2 with an HDR10 video stream and dynamic metadata that is standardized by DVB. We hope this hands-on demo has generated some ideas on how you can easily produce and distribute HDR in a cost-effective way while maintaining a high-quality SDR service for legacy TVs. More tutorials and demos are available, and we will be glad to organize some specific sessions with you if you are interested. We look forward to hearing from you soon.